Hi guys, it's week 9. We're starting our new unit, so we're looking at lesson 101 and 102. So let's go ahead and flip over there. Lesson 101, we're looking at ratio problems involving totals. So we set up ratio boxes all years when it's number of girls to boys, or this type of flower to that type of flower, or whatever two things we're comparing. Now all we're going to do is we're going to add in a total. So we're going to have a third row in our ratio box. So again, if we're looking at boys to girls and how do we come up with a total? Well, pretty simply, two things we're comparing, we add those up, and that gives our total for our ratio. Because sometimes we want to know, boys, how many do we have, or girls, or what is the total? Sometimes we're given girls or boys or the total, and we have to work backwards to find the other. So still comparing two things, it's just then we can add those together to fill out this by adding the 2, 5, and 4 in this example together to get 9, and then fill in whatever we have here, and then it's going to be the exact same thing we've done all year. Set up your equivalent ratios and then cross multiply and divide. So in this example, it was 5 boys to girls, which is a total of 9 for our ratio. And then we're told if there's 27 students and we want to know how many girls there are, and we're going to say 4 over 9 equals G over 27, or whatever you're using for your unknown. And then we cross multiply and divide, and we get G equals 12. And then again, anytime we're working with these, always look back at the example and make sure that your number makes sense. It's not way too big or way too small, or if it's an example where you need to have a whole number, like actual count of students, we can't have 27.5 students, or we can't have 12.3 girls students or anything like that. It has to be a whole number. So always just look back, quick spot check, because sometimes if something doesn't look right, that's your instinct telling you to go back and check and see if you can get it right or figure out where you went wrong. All right, our example here, the ratio of football players to band members on the football field was 2 to 5. Again, the order we read is important because it's 2 to 5, not 5 to 2. Okay, altogether, there were 175 football players and band members on the football field. How many football players were on the field? So first, we're going to set up the two things we're comparing. Okay, so I'm just keep doing that. Okay, our football to band members, and we're told it's 2 to 5. So again, ratio and our actual. Again, we can do actual and ratio. It doesn't matter. We just usually do ratio first. And then we're going to add in a total down here. So it was 2 to 5. So 2 plus 5. That tells us our total has to be 7. Even though we weren't given that number, you can see how we came up with it pretty easily. And then we're told there's 175 football players and band members. So 175 is our total. Right? We want to know how many football players were on the field. So we want to solve for x. So we're going to say 2 to 7 equals x to 175. These ratios, or when we write them as fractions, have to be equal. And then we cross multiply. 7x, 7 times x, 2 times 175. And then we divide. So 2 times 175 is 350, and we divide that by 7. So x equals 50. And then if we were asked to find the band members, we could do the same thing. 5 to 7 equals y to 175, cross multiply and divide. Or we can say 175 minus 50 equals this number. That's probably what I would do because that would be less time consuming. But either way, we would get the same answer. All right, those 3 practice set problems we will go over together. So let's look at lesson 102. We're looking at mass and weight. So this will deal with some things in the metric system, which we don't use a ton of. They use it a lot in the medical field. They use it in other countries all around the world. I think there's 1 or 2 other nations that use the U.S. customary system that we like miles and feet and pounds and ounces and inches and all of that versus millimeters, centimeters, meters, kilometers, kilograms, milligrams, and all of that. So, but again, understanding it's important because I noticed in the Generation Genius videos, they're always using the metric system for whatever reason. And there actually is a little bit more rhyme and reason to the metric system. As you notice, it's always 1 and then 0, 0. So it's always base 10 of something, 1, 10, 100, 1,000, whatever. So just to give you an idea, okay, so mass, the amount of matter in an object is its mass. So sometimes we use mass and weight synonymously, but there is some slight differences, but we'll talk about that. So about a grain of salt is 1 milligram. It's very, very small. A gram, a paper clip, again, it doesn't weigh that much. And then a kilogram, the textbook you have would be about a kilogram. A kilogram, weight-wise, is about 2.2 pounds. So if you ever watch Olympic weightlifting or something and you're like, oh, they just did 400 press over their head or 300 or whatever. I don't even know what the world record is. And then you realize they're talking about kilograms. You realize how insanely strong some of those people are. If we're talking about the U.S. customary, an envelope and a letter is about 1 ounce. A shoe is about 1 pound. Then a small car is about 1 ton, which is 2,000 pounds. Okay, so if we're looking at these examples, and again, I don't expect you to have all of these memorized. That's where using your reference sheet is going to be very, very helpful because you may have a test question that just says, how many centimeters are in 3 kilometers? And if you have your reference sheet for you, you got to do a little bit of math, but really it's just matching up the conversions in units and from centimeters to meters to kilometers, and then multiply it by 2 or 3 or whatever, and you're done. So 2 kilograms is how many grams? Okay, well, kilograms, again, we can look at our reference sheet. There's 1,000 grams in a kilogram. So 2 kilograms, we just multiply that by 2 and we get 2,000 grams. Okay, then when we're adding or subtracting our units, that's where it's important to know, that our units that we end up with make sense. So if I have 7, LB is for pounds, and then OZ is for ounces. Okay, don't know if we've ever said that, but pounds and ounces. Plus 2 pounds and 6 ounces. Okay, so just like with our numbers, when we have decimals or starting in the ones or tens or wherever, we think about our place value. So we start to the right and then we work our way to the left, and then anything we have, just like when we have this, we start all the way to the right. Well, 8 plus 9 is 17, so we put the 7 here and then carry the 1 up here. 1 plus 1 is 2, so it's going to be the same concept here. So we start to the right, just like we did here. 12 plus 6 is 18. Okay, and then this is really 1 pound, 2 ounces. So then we want to add that 1, and we can do this before or after. Oh, I keep doing that. So now this is 2 ounces, and we just carried that up here. So 1 plus 7, 8, plus 2 is 10. So 10 pounds, 2 ounces. Or if we would have ended up with 9 pounds and 18 ounces. That's fine. We just need to remember to convert this. Okay, for every 16 ounces, then we move over to a pound. So this, we got to move a pound over here, and we're left with 2 ounces. Okay. And then when we're subtracting, we may have to borrow. It's still pounds and ounces, 16 ounces in a pound still. So let me think again. We're going to start furthest to the right. We're subtracting. We may have to borrow from the number to the left. So let's say we have like something like this. We go all the way to the right. Well, 3 minus 4 is -1. So we can't do that. So we borrow from the tens place. We leave that. And then this becomes, we add 10. So it becomes 13 minus 4. And then we're left with 4 minus 1 and do that. So it's going to be the same concept right here, because 10 minus 12, well, that's a negative number. Oh, I have this in there. Why I filled that in there. So 10 minus 12, we can't do that. So we'll take a pound from here. 9 pounds become 8 pounds, but then we add, this is where we need to know our units, because if we just add a 1 or we think there's 10 ounces in a pound or something, we need to remember there's 16. So we had 16 here, that becomes 26. 26 minus 12 is 14, and 8 minus 7 is 1 pound. All right, we'll go over that practice set together, those 2 lessons for this week.